The purpose of this mini lecture is to talk about the process for naming ions. When you're given the symbol of an ion, how do you come up with the name of that ion? And we're going to go through the steps, so we're going to go through the process and outline that. Then I'll give some examples of that, and then at the end of this video there will be some practice problems for you to work on, and at that point you can pause the video and see how you're doing on this subject. The first thing you should do when you first look at a symbol of an ion is to ask yourself, is there more than one element in that ion? If there's more than one element, what you're going to do, in my class at least, is you're going to go in and you will look at your polyatomic ion chart. The chart we use, they've kind of saved on some space by just putting down the name of that polyatomic ion, and you have to remember to add the word ion. It's always important when we're naming ions to include that word ion. Some of the ions, the names would be identical to the element, and we've got to have that word ion in there to distinguish it. So we'll always be adding the word ion. If there's not more than one element present, then what you're going to do is you're going to ask yourself, is the ion an anion? Is it a negative ion? If it's a negative ion, what you're going to want to do is figure out, well, what element do you have? Okay, so if it's an ion, or if it's an anion, you're going to find out what element you have. You're going to take the element name and change the ending to "ide," I-D-E, and then you'll add the word ion. Okay, and if it's not an anion, if it's not an anion and it's not a polyatomic ion, then it's definitely going to be a cation. And the next question you should ask is that cation, is it a metal that's in group 1A, 2A, or 3A, or do we have silver, zinc, or cadmium? If we have any of those three, or the 1A, 2A, or 3A, if that's the case, then what we need to do is just identify the metal, name the metal, and then just add the word ion. So you see that word ion is important because if you don't put it in there, it sounds like we're talking about the atom and not the ion. And if it's none of these, okay, it's still going to be a cation. It's just a cation that's going to be somewhere in the transition metals, or it might be tin, or it might be lead. And in which case, what we need to do is we need to name the metal that we have, and we're going to give it a Roman numeral to indicate the charge on that ion. So whatever the charge is in the symbol, that's the Roman numeral we're going to use in our name of it, and of course we add the word ion. So let's go through some examples here. Okay, so I just shrunk down this chart a little bit, and our first example is PO4 with a 3- charge. And again, it's really important when you're writing these, especially the polyatomic ions, that we know what's a subscript, because the subscript is going to tell us how many of that particular atom are in this polyatomic ion. And we also know what's our superscript. Our superscript tells us the charge. And it's always important when you're writing element names and symbols that if it's a new element, it starts with a capital letter. If it's a second letter, it's got to clearly be lowercase. Here, our second letter is the same height as our first one. That says we've got two elements here. This is phosphorus and oxygen. If the O was a lowercase, of course, we'd have polonium. So we've got a combination of phosphorus and oxygen. There's more than one element. So we're going to use our polyatomic ion chart. We look up this ion on the chart. We find it's the phosphate ion. And our chart just says phosphate, and we add the word ion. Next example, we have O2-. We see this, we say, well, there's only one element there. So then our next question is this an anion? And we look and say it's a negative ion. Yes, we have an anion. So what we have to do is identify the element. Of course, we have oxygen. And what we're going to do is we're going to change the ending. So we're going to knock out that YGEN portion of it. We're just going to use the OX. We're going to add the ending of "ide," and then add the word ion. So we now have the oxide ion. Next example, Al3+. There's only one element here. It's Al. It's a positive ion. It's a cation. It's not an anion. So then we look, say, is on the periodic table, is this in group 1A, 2A, or 3A? And we say aluminum, yeah, that's in group 3A. If you're using a different version of the periodic table, it may be listed as group 13. It's just a different designation on periodic tables. So we say, yep, this is a 3A element, so we're going to name the metal. Of course, it's aluminum. And for this one, we don't need to do anything else except to add the word ion. So we have the aluminum ion. And our final example, Mn2+. Again, we have only one element, so there's not more than one element. It's not an anion. It's not in 1A, 2A, or 3A, and it's not silver, zinc, or cadmium. So because we have one of these transition metals, and since the transition metals in tin and lead, they can form different ions at different times. So we have to give some extra information in the name to help us figure out which ion we're talking about. Of course, we have the element manganese. So our metal is manganese, and we are just going to take that 2+ charge to it and write it as a Roman numeral. So this will become the manganese 2 ion. So we have some examples here, or not examples, but some practice problems for you to work on. So at this point, you may want to pause the video and work these out on your own. And when you're ready, just restart the video. So we're ready to give the answers, and the answers to these practice problems are as follows.